Hello, this is Johan Koelman, and I saw a video on the internet about explaining the software that someone wrote. The source was discussed, and I thought I could do the same with one of my games. So I chose SnakeBingo, a low-res 1K ZX81 game, and I will explain you how the game works. First of all, I have a base model for the ZX81 code in low res, which is less optimal than the model I use for my 1K high res games, because you need to set and use the d-file system variable, and so I can't use that system variable, but I will explain you how the game works. As you might know, games on the ZX81 load from the address 4009 hexadecimal, and that's also the place where the game is starting with the program. End of screen is how the size of my screen is. The number of lines I have with the size of the lines is the size of the screen. What does this program do? First of all, when you load a game on the ZX81, it will read what to do with next line. If this value is 0, then it won't do anything. It will just load the game, and you have to start the game yourself by go to or with run. Now, since this is defined with the position basic, it will go to the basic and it will execute the basic line, which is set there. Now, what is the basic? This part, you might not see it, but this is basic. In fact, it's our system variables, it is a piece of basic, and it's a piece of machine code. So it has three functions in one game. How do you get memory optimal use? In this way. First of all, a basic line consists of a line number. This is my line number, 2 bytes used for, but I also placed a piece of code in it. Next part of a basic line is the size. Now, you don't need the basic to check on the size, so I can write here anything I will write here a jump relative. The next part of the basic is the basic itself, which is this part. This is the randomize user 0, this is the character 0, and this notation here is the shortest floating point notation to define the address 4009, and after this the basic will start the machine code and go to this part in machine code, and the first thing it does is it sets the H register to the high byte of the display file, and then it goes to init1. Init1, it says set the low byte of the display file and go to jump relative init2. Why are these small jumps in here? Because some parts of the machine code I cannot use, something like the last key value. This is used by the interrupt, so I can't code any program here. It has to be done by the program itself. It has to be used by the machine. So I can't code anything here or it will crash. This part I can use. I will explain later what I will do with this, but that's a table I will fill later. So what it goes to init2. Let's go to init2. Init2, and we repair the display file of d-file. That's the first thing we have to do. So at this moment, when an interrupt should occur, the interrupt will take the value of the display file and will show the display file. Next thing I do is I define my end of screen, the high byte of it. These 2 bytes are used by the ZX81, but has a value which is not a problem when the game is loaded, so I can load my end of screen as well. And this frame count is decreased by 1 after loading. So in fact, this is the command write E9 to the content of HL, which is a definition to define my end of screen. And the next thing we do, we jump to init 3. Let's go to init 3. Init 3. Here it is. This is the display file, as you can see. So this part of the screen is what's displayed. It says SnakeBingo. It says what's my high score. It says what's my current score, and it shows my bingo card. The letters A to O with few new lines. After that, we get a block of inverted spaces for the screen. As you can see, we have the length of the size, screen length, one line of inverted screens is defined. Now what we do is we set the stack pointer at the end of memory. We will do that again when the code is running. And what we do also is we use the flag count of the interrupt. We will reset it a long bit so we can delay the interrupt, so we have time to fix the screen as we want to have it. The A register has the value of 09 in it and has to become 255, 256 before it gets an interrupt, so we have time enough to repair the screen. Now the first thing we do is we have a random routine and we place that over the system variables, over next line. That was the one that was started, the basic. We don't need it anymore. We are in machine code, so we can use that part of the machine of the system variables to place a routine which we have temporarily stored on the screen. Now the same goes for the tail table. We need information about the tail table, and we can place that on the start of the RAM at 16384 4000 hexadecimal. Same goes for the key table. We can place that in the keys which I mentioned before, and at that moment we have stored all the information, but now we need to repair the screen. And we had one screen line we had defined, so what we're going to do, we're going to place this screen line over this info and also over this info, which still needs to be executed, but we do that by setting a carry flag, and we jump to game code -3. Now if we go to game code, -3, that's this line. We have set the carry flag, so it will go to a routine in the ROM, which is nothing more than a copy routine LDIR return, so it repairs the screen and the game will go to this part. Now this part of the game simply reads the last key pressed, it subtracts a 191, or it will read the port H to new line, and if one of those keys is pressed, we start the game, and A becomes 0 because we do a subtraction. So the next thing to do is to clear the score. So we point to the score, we set it to 0, we go to the next, and we test if we have reached the end of the score, which is a space, which is the value of A coincidentally, and it clears the score. Then we increase A so we can place 1 star at the screen for later on. Again, we repair the stack pointer, not needed on first go, but we need it on restarts, and we set the number of stars. This number will be altered when we go to the next level. Then the value of A will increase by 3 before it writes this value. We will explain later. Then we have a screen, the full screen, this small routine. Go to the screen, write an inverted space or clear the screen, go to the next field. Is it a new line? If it's not, if it is, then we go to the next screen. If it's not, it might be the end of the screen, which is the E9 arrow to end of screen, and if it's not, we clear the whole screen. So this routine clears the whole screen. Next thing to do after we start is to place randomly the bingo card. and the bingo card are just letters A to O which need to be displayed on the screen. So what does this routine do? It gets, first of all, it indicates that the current letter is not taken, and then it goes to the routine random XY. I will show you. Here it is. First of all, it will take a random number because we have copied that over the next line routine. It stores it in the value of C. It tests if it is the column 10. If it is, then we need a new random XY because that's the start column of the snake, and we don't want to interfere with the snake after starting. We want to have the snake free path in the first go. Then we test if we're still in range. If not, we will find a new position. We will go all the way until we find a position in range. Then we get another random number. We store it as the Y position, and we test again, is it in range. After this, it is in range, and we check which field is it. Is the field already taken? Is there another letter placed on it? So it has to have the value of 128 before it can be used. If it's not, so it's been taken, we do simply get a new value. Otherwise, we get the bingo letter from the bingo card and we write it to the screen. That's what random XY does. We go back where we were, random XY, yes, so we wrote it on the screen. Then we go to the next position, we test if we are at the end of the bingo card line. If not, we have to write other cards. So at this moment, all the cards are written on the screen. Then we have to define how tall will the snake become in the first one. So we will make a 10 step, 10 size 10 snake. After starting, it will grow to 10 position before erasing the tail. And that's also the direction we will define to go in the first direction. The value of 10 is the key number of Q in a ZX81. So next thing to do is we define how many cards we need to take. 15 cards we need to take, A to O. And now we're going to write the stars on the screen because we need to have stars error positions on the screen as well. So the first level has 1, it will go to 4, 7, 10 and so on. So it gets the inverted star like before, it will write it to the screen until all the stars are done. Now the next thing we have is this weighting routine, and all it does is it reads the value of the frames, it subtracts 50, it compares to the value which will be decreased on every interrupt the machine will make. 50 interrupts in a second, so 50 counts is 1 second delay before the game will start automatically. And as we said, position column 10 is a free position, so we start at 10.10, which is also free, and this value of E is a hidden item on the screen. It will show you what the snake has and how it looks. It's a white space it will show, but it's also information about the direction the snake goes. In this case, if you go up, the previous direction was down, which is indicated by the 54, which will define as a space on the screen. Another 1K snake option uses a snake which seems to have all kinds of O's, but it's a Q, an O, a 0, just to hide which direction the snake goes. I have done it in hidden commands, so you still see a single space and it looks like a snake. Well, we're gonna play the game. In the play loop, we save the position we have, we get the field. Now we're gonna test if we have hit a tail. When there is no byte, no byte set, it's not a black space, then we have hit tail, so we have end of game, it's game over, and we play another game. Otherwise we have an inverted field, but which value does it have? It might be a space, so the game has to continue like this, it's tested, if so we can set it, but it can also have a letter on it or a star, so it will grow. First we define that we have 10, we swap to alternative registers to save the bytes, and then we say we have a growth of 10 positions. So we're going to test, did we hit a star? If it is, we add 10 positions to the snake. Then we're going to test if it's 5 positions. This is when you have taken a number from the card or a letter from the card which is not in order. If you take it in order, the tail will grow by 1 position, if not it will grow by 5 positions. So we have to test, did we take a number in order? Which is the next thing we will do, which is this small routine. We set B to 2, and all it does is it checks what is the first number, the first card to take. If it is taken number, if it's not taken, then it will decrease B by 1. Then it's gonna test if this is the current card we had to take. If it's not, it goes back until we found the current card to take. If it's the right one, B will have the value of 1. If it's the wrong one, B will have any other value. So, first of all, we indicate on the card that we found which one we took. We're going to say you don't have to take it anymore. This is when we are at the end of the screen. We can add 3 new stars, so this is for when we are, this is preset only, we have to do nothing. If we are still playing the game, it is needed when we go to the next level. So, we're gonna count the number of cards we took. We decrease by 1. If it's reached 0, we've taken them all, we can go to the next level. If not, we decrease 1, B by 1 again, and we can go to the score and C is the right positions. We've taken it in the wrong order, we need to add 5 positions to the snake. If not, we only add 1 position to the snake. So, we score 10 points because we took a position on the screen, a character on the screen. You get 10 points for a character. That's what we got. Great. Now I have to set the tail. Now first of all we take how many steps we still have to take, and we add the number we according to the character we took, and we write it back again. Now we know how long the tail will grow. We will write a piece of the tail on the screen. That's what we do here. First of all, now we need to check when have we reached the end of the tail, and do we need to erase the tail. So first of all we make a maximum defined tail of over 1024 positions. Trust me, I never had a game with such a long snake. Then we set the frame counters back to 255. Why do we do that? It's a delay count and it works quite well on the emulator for the ZX Spectrum. It's a nice trick which I not normally use, but in this game I do. Now we have some time to find the end of the tail. First of all we decrease BC. If it's reached 0, then in some kind of way we're in a loop of the snake. So the end of the snake and the head of the snakes are connected, and we get in a loop and you never find the end. If it does, it will simply tell it's hit each other and it's end of game. If it's not, you're gonna take the current direction of the snake, which is stored previously here or in a few loops ago, and when it gets that data, it will check on the tail table which direction to go, and it does read new registers of DE for it, and when it's found the right direction, it simply changes the position on the screen to the next by this addition. Next check to do is, did we find the end of the tail? If not, we have to find the end of the tail. So at this moment the HL register indicates the end of the tail. However, we need this is the position beyond the end of the tail, but we need to have the last position of the tail, so we repair it back again. This is now the final position of the tail. Now we still wait a few frames just to get a good display, and if it has passed this test, then we continue. Do we have a growing tail? If it is 0, we must erase the tail. If it's not 0, we simply write the new value back to the steps, and we skip this step by hiding the erase command in a simple load HL with the value register. Otherwise we erase the tail. Now we have moved one position, which always adds 1 point. Great, we have moved a point. And now we're going to do the controls of the game itself. So we get the last key pressed. We test it if any key is pressed. If not, it will remain 0. If it's otherwise, it will get the value from the ROM routine to the key that's pressed. Now we hide again the last value in the HL command, and we check with the current value, the first value we have. If there's no key, it's 0. If there is a key pressed, we will check which key did we press. That's this loop. And by the way, if we found the key, it will write it as previous direction. If we don't find a matching key, which is here, tested 5 keys, then we go back up here and we take the former direction we had, and this is the direction the snake will continue to move. So once again it goes through, then it will find a loop and it will jump to the move routine, which is up, down, left or right. So if we go to up, down, left or right, let's say we go up, we decrease the Y position by 1 and we set the hidden code again for down, and we make a move test. If we go to move test, which is here, we check if we have hit the screen on the walls, if we hit the vertical or the horizontal wall. If not, then we continue to play the game. If we did hit, then it's end of game, game over, bite our tail or something like that, and we're gonna check what is the score we got. So this is our score table, this is our high score. We repair to the first position, that's this one. We check 5 positions of the score, but we already passed 1, so we check what is the current high score value, what is our current own score. If it's the same, we will find a high score again. This loop will continue until it doesn't match. And when it doesn't match and we have the exact same score, then after our score there is a space, and after our high score there's a new line, so it will automatically find the difference, and then at that moment there is no carry flag set, so there is no high score. But if there is a high score, so the current score is higher than the high score, the remaining bytes are copied over the high score and it is set. And then the routine goes back to waiting again for a new line to start a new game. Well, that's the whole source of SnakeBingo. Hope you enjoyed the explanation. Hope you understood the explanation. If not, be free to ask me anything. And If you like it, I might do another. Just leave that in the comments. Thank you.